Okay. All right. So I was just messing around with some of the games that my students have done uh, on my website. I always post the maybe like the 5 or so best games of the year, or it's more than 5. It's like probably 12. I do like a gold, silver, and a bronze, and then when the next group comes in, they can kind of see um, what games that the other kids are able to do. And when I get before I close today, I'll at least show a few to just show you what you can do with Greenfoot. And really, once I get the students' interest sparked, they do all kinds of things with it. So back to our shooter game today. I'm gonna do part 2. The main objective is to get player to be able to move and direction and position. We got it last part 1. We got it to be able to shoot. So we're going to build on top of that to be able to rotate, change position, and then also to add a bad guy or an enemy and get them to interact with each other. So that's the goal for today. So let's see. That's one of the games I'm going to show. Okay. So getting back into Greenfoot and yeah, okay. This is the first one. All right, so here's shooter. All right, so I'm going to go back into player and go back into player. And right now we just have it to where if we hit space, we shoot these bullets. And I think that's probably too fast, so I might slow that down. But what I want to do is get the player to be able to change positions, X coordinate, Y coordinate, and rotation. So all right, here we go. So yeah, and this is where we set the bullet speed right here. I'm going to make it a little slower just so it doesn't seem so fast. But what we want to do is, last lesson we talked about is key down, checking to see if it's a space. Now we're going to check if Greenfoot dot is key down, left, which is the left arrow. So if the left arrow is placed, then what we want to do is change, essentially move the X coordinate of the player some to the left. So there's a method in the actor class, which we are building off of actor here, which allows you to set the location. So you can't set the X coordinate, you can't set the Y coordinate, you have to set the location. And a location requires the X coordinate and the Y coordinate. So I'll call this set location method, which needs to get an X coordinate and a Y coordinate. And the Y coordinate is going to remain the same, but the X coordinate is going to be the current X coordinate minus 1, and then again the Y coordinate is going to stay the same. So that will allow me to move left. Okay, and one important thing that I want to talk about, which is kind of fundamental to any programming language that you ever do, is if and else if statements, and how they differ from if statements or an if else statement. And I'm just spend a few minutes talking about that. So I'm going to get the 3 conditions. So there are 4 conditions. There I have added 1 to the x coordinate if I'm going right. And it's kind of counterintuitive here when you first start doing these 2D games, until you understand like 2D arrays. But whenever you the y coordinates of the world get bigger as you go down. So if I'm going down, I'm actually going to, the x coordinate will stay the same, and then the y coordinate will not get subtracted, but it'll actually add 1. So that's a little counterintuitive at first, but that's how it works. And again, when you learn 2-dimensional arrays, it makes a lot more sense. So I'm going to go up here, and that'll be the opposite, -1. So I want to spend just a second talking about, well, first I'll run this, and you can get a chance to see kind of how the motion works. So this is left, this is down, this is right, and this is up. Okay, we can still shoot. Okay. So now we have that. The problem right now is if I hit down and right, or yeah, right and down, this is what happens. You know, I can respond like this. These are 1 click at a time kind of thing. But if I hold it down, he's only moving to the left or right. So what's happened, if I go back in here, is to understand that this is an if, else if, else if, else if case.
Craig, would you reshare your screen, please?
Yes. You see it?
No. Oh, there it is. Okay, got you.
Okay. All right. Okay. So this is an if, else if, else if, else if case. And essentially the way that works, and what's important, again, in any language it'll work like this, is this condition gets checked if this condition is not true. So if you're not hitting left, then it'll check to see if you're hitting right. If that's not true, it'll check to see if you're hitting down. And if that's not true, it'll check to see if you're hitting up. And then some people would put in an else case here that would just do nothing. So if none of those things are happening, we just wouldn't do nothing. We would not do anything. But it's kind of repetitive. It's not needed. So what I want to think about now is I want it to be able to move left and up, for an example. Okay, left and up. So the one way that you could do it is another condition that would say if you're hitting left and you're hitting up, then change both of those 2 coordinates. You would change the x coordinate by 1. You would decrement or you would get y -1 to make it go up. That's one way to do it. A better way to do it, which is the way that I'm going to do it, if you think about it, an if case, I can have separate if statements. And you can see the way that the kind of the color changes. I'm trying to take that if. See how the color changes. Like these things aren't connected anymore. They were connected. Now they're like 4 separate if statements. But that's kind of what we want, because now 4 if statements means I can be touching left and down. This will be true, and this will be true. So it's not exclusive like the else if, where it says if this is true, only would you check the 3rd condition if the 1st condition is not being met. Now they all 4 could be met, and if I pressed all 4, it respond as best it could to do all 4 of those things. But now left and right will work a lot better. So all right, so let's try that. and this is down and right. So now we get a little bit better motion. Okay, so we still got our shots here. Okay, so what I want to do now is get the player to be able to rotate. So I have to give 2 other keys to where it can rotate. But also, whenever it rotates, I want the bullet to go at that angle. Okay, so the bullet is going to go at that angle in which the player is rotating. So I'm just going to do 2 buttons. I do X and C. You could choose any 2 buttons close to the. I do them close to the space bar, because then you could hit the space bar to shoot, and you could also hit X and C to rotate. But one's gonna rotate clockwise, and one's gonna rotate counterclockwise. And I'm doing a space here, but really these are just all separate if statements, and all of these could be true. Would happen. Okay, so what I'm going to try to do here is if Greenfoot dot is key down, I guess I'll do X. Now, just like there's a set location, there is a set rotation. So rotation, as I mentioned in the first webinar, is the direction that the actor is facing. Starts off to be 0, which is east, which is why the bullet shoots east. And you can set the rotation. You could even set the rotation by 1 less than the current rotation or something like that. But there's actually a built-in method in Greenfoot which just turns the player by 1 degree, or whatever you pass here. Okay, so I passed 1 as a parameter, and it will turn 1 degree clockwise. Okay, then I can check the other. And there's actually a turn -1, which just turns 1 degree in the counterclockwise direction. Okay, so now if we run it, the player will be able to rotate. So first I'll show this is moving again. Now he's going to start rotating, so I can rotate him in and out, and I can shoot. Okay, now the shots are all going east, regardless of the direction of the player. So, and that's because whenever we put a bullet in the world, we put the bullet at the location of the player. And I'll show that right there. This is in the player class. Whenever we hit space, we add a bullet object to the current XY coordinate. This XY coordinate right here is the actual player's XY coordinate, because that's the class that we are in here, player. But what I'm also going to do right after that is I'm going to change the direction of bullet. And remember, direction is called rotation in Greenfoot. So bullet dot set rotation, and I'm going to set the rotation to the current rotation of the player, which, remember, we can change now. So it starts off to be 0, but once we change the player's rotation, this will change. So bullet dot set rotation, and it's just get rotation. So again, I'm not saying this is not bullet dot get rotation. I'm not getting the rotation of the bullet. This is in the player class. So it'll get the rotation of the player, and it'll set the rotation of a bullet now. And then once the bullet's in the world, this is what a bullet does. This is the act method. Basically just move at a certain speed. Remember, the move is this is a certain number of pixels that it moves every count of act. That's it. When it gets to the edge, we remove it. But that's essentially all it does. So once the bullet's in the world, it knows how to act. Okay, so I'll move them around. Okay, and now I can rotate, and now when I rotate, it's going to go in the direction that he's facing. Okay, so now we got a working player for the most part. And and when we reset, it comes right here. Okay, so the next thing that I want to do is create an enemy. And there's a couple of different ways we can do it, because if we're essentially playing this game as if we're playing a random or a computer. So that's actually a lot harder than it may sound. Is to create like random movement from an enemy, or to make the enemy kind of track a player. It's kind of tough. But what I can do is just get the enemy to kind of have like a random movement, which will still be, probably track pretty good around the whole world. And then we can get them to interact. Okay, so basically what I want to do from here is create an enemy, get the enemy to correspond to the player, and then I will create a new world to where they kind of start off together on the board. So I'll create this is again called a subclass of actor, and what that means, again, these are like really important terms that you don't have to understand everything right now, is I'll get a bomb. You don't have to understand everything now, but a class is a very important thing, and a subclass is a very important thing. But right now, just understand that everything that an actor has or can do, an enemy has and can do that. So an actor has an X coordinate, has a Y coordinate, has a rotation, it has an image. So an enemy has the same thing. Okay, and all I'm really going to try to do in enemy is to get it to have random movement. Okay, so in any language, a random number generator comes up a lot, especially in or simulation if you're doing something with probability or something. But in games, it comes up a lot as well. So the way that it works in Java is there's a couple of ways, but probably the most common one is math.random. And math.random gives a number between 0 and 1. So 0 is inclusive, 1 is not inclusive. Meaning you could get 0.9999, but you can't get 1 from math.random. Okay? You can't get 0. So you could do, one thing I could do is I could get it maybe a random rotation. So a random number in between 0 and 360. Okay? And set the rotation of the enemy to that, and then have it move. So then every time act is called, the enemy will get a new random rotation and then move a certain amount of pixels. Okay? So again, it's a number from 0 to 1, and if I multiply that by 360, because I'm talking about a random rotation or degrees. If you multiply 0 by 360, you get 0. If you multiply 1 by 360, you get 360. And since we can take on any number in between this range, we can get any double in between, or any decimal. That's what double means. Any decimal in between 0 and 360, except 360, because we can't get 1. So anything from 0 to 359.999. Okay. And I did int r equals, this is something called casting. You don't have to worry about it too much right now, but it is the decimal part of it. So if I had 157.36 degrees, it would be 157 as an integer. And even if it was 157.9 degrees, it would round down to 157. So that's the way it works there. But it is it makes it become an integer and loses that decimal. So if I set the rotation, this is setting the rotation of enemy. set the rotation to R. Okay, set the rotation to R. This will happen every time act is called. Okay, and I'm also going to move, let's say, 5 pixels. So it'll move in the direction that it is currently facing. Okay, so let's take a look. I'm going to have to drag one in right now. So if you right click, or on the Mac double click enemy, you can bring an enemy in. And if you act, you can kind of see what's happening there. I'm just hitting act one time. So random direction moves by 5 pixels. If you run, it gets kind of like the spinning action, and maybe it would be better if I did like some spinning around. Okay, and that's kind of the random movement. Again, it's kind of hard to get it to track the player. So something that's a lot of kids want to try to do, but it's kind of tough. So we get this random movement, and the last thing we want to do is get if a player, shoots it, to be able to get it out of the screen. Anyway, trying to get it to, if we shoot it to get out of the screen. Okay, so the way that's actually going to happen, if you think about this would not be an interaction between the player and the enemy. This would be an interaction between the bullet and the enemy. So if the bullet touches the enemy, we want it to go away. So let me, because I'm not exactly sure what the name of this thing is. This should be a good practice every time. Go and look at the API of these things. I double click it. I was just bringing. Oh, I need to double click actor. So if you double click actor or double click world, it brings you the API, and I can look in here and see all the things that I can get. Intersecting objects, which are, so we probably don't know what that is yet. I can. This is tells you whether it intersects it or not. This is another Boolean method which tells you if it is touching it. And this one would be pretty easy. Remove touching. So it removes one object of the given class that the actor is currently touching, if any exist. So if any exist, if they are touching it, will remove it. So we would need to do this in the bullet class and tell it to remove touching the enemy. So if the bullet ever touches an enemy, it would remove the enemy. Okay, so we'll get that, and then we will see if we can set up the board. So double act, or the void act, let's call remove touching, and it would be, this needs to be in bullet. So again, we're going to remove what we are touching. We are going to remove the enemy. So this needs to be bullet. Remove touching. And the way that this works is you give it a class. So not an object. So remember, we're telling it of any type. If we touch any type, we'll remove it. And so if I have multiple enemies, which is where I'm going to go in just a few minutes, which will be the last thing. If I have multiple enemies and it touches them, it will just remove the one that it is touching. But if it removes anything that is touching this class, this is enemy.class. I still need to drag an enemy in. And it's random. Now we can remove it. Okay, so that method was built in that says remove touching, which is going to be used in, I would say, a lot of different games. Even if it's not a shooter game, a lot of times things are going to get removed if they interact or touch on the board. So two more things. I'm going to go into my world and first of all create an enemy to where it will start the game with an enemy in the world. So just like player, here I'm creating a new player or a new enemy. By the way, you could put this, I think I will, since we kind of said what this whole math.random thing is. There's 600 horizontal pixels and 400 vertical pixels. So layer starts at 300, which is in the middle of the grid. Now I'm multiplying math.random, which is a number between 0 and 1, by 600, and getting something in between, a random number in between 0 and 360. I'll do the same thing for the y coordinate. And then what that's going to do is every time we start the world now, we're going to have, and you can reset, the player always starts there, but the enemy will start at a random position. Okay. Okay. So and the last thing that I want to do, I do have time, is instead of just starting out with one enemy, I'm going to start off with several. Okay, and whenever you want several of something, you can use something called an array. So I'm just going to create several different, well, it's going to require me to do a for loop. So yeah, it's not going to take just a minute. So let's do private enemy enemies. So now what this does now is, there's an array. You can have an array of ints, you can have an array of strings, you can have an array of doubles. Here I have an array of enemies, of type enemy. And instead of creating one enemy right here, I can create, let me just start with 5. So essentially, when this array is created, there are 5 spaces. It's actually null, but 5 spaces for enemy objects. And what I can do is, I would use a for loop, but instead of kind of starting that with a little bit of time, I'm just going to copy and paste this line of code. So what I'm going to do is, this is one enemy right here created. It doesn't have a name like enemy like it did before. It's just an object. But I am going to, I guess I don't need an array. I could just copy this 5 times. But if I have multiple copies of this, then I can start multiple in the world. Next webinar, maybe I will try to show an array to get started on that. Let me just take this back. So right now I'm just adding an object, new enemy at a random XY coordinate, or a random horizontal and vertical. And I'm just doing it a couple times. So now whenever we restart, and these all have random XY coordinates, but you can play the game. Okay. And you can add things to that, like a counter or a health. So if the enemy hits the player, we lose health. We don't necessarily die. We just, if we get hit several times, then we would eventually die. But that is what I want to do for Greenfoot. And before I go, I'll just show one quick. This is probably, oh, this is one game that a student created last year. It's a little glitchy, like you can get hung up in the walls, but that, once you get kind of going on Greenfoot, students can get hooked and really do a lot of things with it. Okay, Brian.